This is Brooke Hedrick testing the Contextual Electronics PowerSwap, the 3.3 volt version for output. What you see on your screen today on the lower left is the PCB. On the PCB, the upper left-hand corner of it is the connections for power, the input power, the voltage. And through that, there's also connections that are grabbing the current that's being drawn into the PowerSwap at that point. And the meter that's showing the current that's being drawn in is in the upper right-hand corner of your screen. It says current at input. Back on the PCB in that lower left-hand corner, you can see the yellow and green wires. That's our output for the PowerSwap. You can see the amount of voltage coming on the output through that display on the right-hand side of your screen that says output voltage / FB or feedback. And right now I don't have anything powered on yet, so the numbers you're seeing on the screen don't mean anything. In the upper left-hand corner of your screen, there's an area marked load. That's the DC load we're going to use to pull on the PowerSwap to see how much amperage we can pull through it and still keep our 3.3 voltage regulated output. And then again, on the upper right-hand corner is the current that's being drawn at the input. Below that is the output that we're getting. At the end of the testing I'm going to do here, I'll also put a probe on the feedback test point so we can see what we're getting for a voltage there. We're expecting about a ½ volt. And then the lower right-hand corner, we have an oscilloscope that's plugged in on that output of the PowerSwap. And that'll just give us an idea of what the signal looks like coming through on our regulated output. All right, I'm going to plug in the 3.7 volt power supply. We're wanting to use a voltage that reflects what we're expecting to come from our LiPo batteries. We know we can hit as high as 3.2 volts and we can fall a little under 3.7 volts, but 3.7 should be around the area that we stay. So right now with no load at all, you'll notice the upper left-hand corner load says off. We've got no load at all, but we are powering the PowerSwap. We're getting 3.3 volts output, and our input's 3.7 volts. And right now we're using about 17 milliamps at the input of the PowerSwap to get that 3.3 volts. And our signal isn't very interesting right now, probably because we aren't putting any load on it. So now we're going to turn on the load. So we've gone up to 50 milliamps is what we're going to draw right now to get started. And we're seeing our current jump from 15 milliamps or so up to about 100 milliamps. So we're drawing 85 or so more milliamps in order to handle a 50 milliamp output. But our voltage regulation is looking good. We're at 3.35 volts, and our output signal looks pretty good, not terribly noisy. So now what I'm going to do is I'm going to start increasing the amperage on the load and see how many milliamps we can pull out before our regulation falls off. All right, so we are up to 100 milliamps and we're still regulated okay. All right, we're at 150 milliamps, and notice our current output is 230, or sorry, our current at the input is 231. So again, we're burning about 80 milliamps just in the board and regulation costs, I guess. All right, we're going up still. We're still, oh, now we're starting to see our output voltage is beginning to drop off a little bit, but we're still hitting the numbers we're looking for, 3.3. Oops, there we go. 220 milliamps appears to be the point at which we start to fall below our desired output voltage. I'm going to back off just a little bit. There we go. So between 210 and 220 milliamps is where we stopped losing our 3.3 volts at our output. And we're using 330 milliamps coming in at the input. So we found out at this point we can't draw much more than 200 milliamps before we're going to lose regulation on our PowerSwap. I am going to next disconnect the display you see for the output voltage that's saying 3.30 right now on the right hand side, and I'm going to connect a probe in so we can look at what the feedback voltage is. Alright, so I've plugged in my probe. Now I'm going to connect it onto the board. There's our feedback test point, and we're getting 0.48 volts. So we were expecting about a half a volt there, based on what Chris came up with and the formulas from the datasheet. So we're pretty much spot on. So that ends my testing of the Contextual Electronics PowerSwap 3.3 volt version. Thanks for watching. This is Brooke Hedrick.